Now we get to learn about the area of composite figures. So composite still means the same thing. It's more than one simple shape put together. Again, the simple shapes that we're talking about are all on your formula sheet. When we squeeze two of these shapes together, it becomes a composite figure. Some of these shapes you might not be that familiar with, like a parallelogram, that's what we see here, and a trapezoid. I think those are kind of new to you. But these formulas are going to be really helpful as we're finding area. When you see a parallelogram, it's just base times height. You could split that into two triangles and a square or a rectangle in the middle. That's way more complicated than just using the base and the height of that parallelogram. Same thing with the trapezoid. You could split it here and split it there, and you can see two triangles and a rectangle, or you could just use this formula sheet. For area, we want to keep coming back to the formula sheet and rely on this as we split up these shapes. It's going to be simple shapes squeezed together. You find the area of each of the simple shapes, put it together for the full area of a composite figure. When I say area in general, I just mean the space that takes up the inside of the shape, how much it takes to cover an entire inside of the shape. So perimeter is the border, that's the length around the outside. Area, it's literally the number of square units it would take to cover a shape. So the biggest word that you're going to see is cover. Square units is an idea that you want to keep coming back to. It's actually the number of little squares that it would take to fill in this entire thing. And the units specifically are squared. So if I talk about feet, it would be feet squared or centimeters squared. The units are actually squared themselves. Or millimeters squared, whatever units they are, that says mm, stands for millimeters. The units themselves are squared. You might also just see it as the word. You might see square feet or square centimeters. If you see that phrase in a word problem, that means you're talking about area. We're talking about how much it takes to cover a shape. So this is going to take a little bit more imagination. You're going to split up the shape. So you want to split the figure into simple figures. Again, the simple figures that I'm talking about are all on your formula sheet. You find the area of each separate shape, and then you add those together to find the total area of the figure. All right, so we're going to split this into simple shapes. This one's already kind of split up for us. We have that dashed line going across the top. I see a triangle there. I'm going to split it here. You could split it here. It really depends on what you see clearest. I see this rectangle and this rectangle off to the side. All right, so I have three simple shapes. I'm going to find the area of each of those, and then you put that together to find the total area of the shape. All right, the area of a rectangle. Come back to the formula sheet. Make sure you know what you're finding. It's a rectangle. We're talking about area, so that's length times width. So I multiply length times width. Doesn't really matter which one's length and which one's the width. You multiply the two dimensions together. 5 times 4 tells us that that has an area of 20. The red shape is also a rectangle. That 12 is misleading maybe. 12 is going all the way across. We don't want to use 12 because we're just talking about this section. 12 takes us from there all the way to there, which is going to include this rectangle. That's including that 4. So we're going to do 12 minus 4 to figure out that that side is really 8. So when I called it a rectangle, I wasn't wrong. I mean, I knew it was going to be a square also, but all rectangles are squares. You can use this formula for both rectangles and squares. This one only works for squares. So I always just think about it as this, but you could use this since it's a square, since they're the same length. S squared is really just S times S. That's the side. S stands for the side length. Here, L and W, when they're different, you have to use that. When they're the same, you can use this. You can use the side length squared, or you can really just use this too. It still works. Length times width, or side times side. That would be 8 times 8, or 8 squared. Those are the same thing. That's 64. So you're again going to have to use what we learned about perimeter. When you have to split up this shape, you're not just going to use the lengths that you're given. Just because 12 is labeled there, that doesn't mean we just do 12 times 8 to find that section. Because this is only 8 units long, or 8 centimeters long. That's also going to be helpful for this green triangle. 8 is also that length. So we have that green triangle at the top. It has a height of 3 and a base of 8. You might be thinking, how do we find the area of a triangle? Well, your formula sheet tells you exactly how to find the area of a triangle. This is our triangle. Now, you might be thinking, which one is it? Because we do have two triangles on here. This is talking about finding the length of a side of a triangle. This is finding the side length. This is finding more of the perimeter, or one side of the perimeter. This is finding the area. So look at that picture. That's showing you that the height and the base are connected at a right angle. The height is how tall it is. The base is that bottom side. It doesn't always have to be drawn as a right triangle. In this picture, we have a right triangle. You can see, though, this is not a right triangle. Even though there's a right angle drawn in there, this is not actually a right triangle. The height goes straight up and down in the triangle from the base to the peak. That's the height. That's the base. We do 1/2 base times height. So in that case, it's pretty straightforward because the height is right there. The base is right there. So 1/2 base times height is 1/2 of 8 times 3, which is 12. That part's 12. That part's 64. That part is 20. So all together, that is 96 square centimeters. This is not any sort of operation. We're not squaring any number. It's just talking about the units. It's saying that it would take 96 little squares to fill in this entire shape. All right, here we have a half circle. We could think about this as a rectangle and a triangle, but I'm not going to do that. I want to make this as simple as possible. Again, it's really up to you, whatever you see clearest. But I see a trapezoid here. A trapezoid means we have one set of parallel sides, and the other sides are not parallel. So we really don't even need to get into those being parallel, what that really means. It just means that they'll never actually intersect. But you can see that they run in the same direction. They're two different lengths, and there's a height connecting them. That's exactly what we see on our formula sheet. This is a trapezoid. We have two lengths that run parallel to each other. They're different, B1 and B2. That's just saying base 1 and base 2. And then we have a height that connects them. Base 1 and base 2 here. The number 1 and the number 2, those subscripts are not operations. It's not saying I'm squaring the base. It's just a label. It's just a name for that base. It's saying base 2 and base 1. It's just to distinguish between these two numbers because they're going to be different. So it's saying I'm going to add those two together inside the parentheses. I do 1/2 the height times base 1 plus base 2. I'm going to write that out just so we're clear on what that is. Area of a trapezoid is 1/2 height times base 1 plus base 2. That's this bottom section. Then I have a half circle on top. All right, let's just deal with the trapezoid for right now. So the height of that trapezoid is 14. That's going in place of the H. The base 1 and base 2, it really doesn't matter which one's which. In your formula sheet, it labels base 1 as the top, so I'm going to keep that consistent. I'm going to say that's 20, and base 2 is 32. Again, notice I'm not squaring this. That's not an exponent. It's saying it's base 2. It's just the name for that base. That one's base 1. That one we call base 2. So the area of the trapezoid is 364. Let's say you really don't like doing the substitution part of this. Just like we showed you with Desmos, you can type this equation, or really this expression. You type just this part, and then you tell it that the height is 14, base 1 is 20, base 2 is 32. And it'll do that substitution for you. You'll find out that that trapezoid has an area of 364. All right, now for the half circle. So this 20 is going across that circle. That dashed line is going all the way across that red circle, or red half circle. Oops. So 20 goes all the way across. That is the diameter of the circle. We do not have two equations for area. We only have one equation that uses the radius. Area of a circle is pi times the radius squared. Just like before, I'm going to use 3.14 for pi. So that's pi times the radius squared. I don't really have the radius right now. I have the diameter. The radius is half of that. I'm going to divide this by 2 and find out that the radius of this circle is 10. That's the number I have to plug in here. So I'm dividing it by 2 there just because that's what the equation uses. It uses the radius. Pi times 10 squared. So that's 100 times pi. That is 314. Again, I'm not rounding. I'm just using 3.14 as my approximation for pi. So the area of a circle that looks like this is 314. That's not really what I have here. I only have the top half of that circle. It's cut off there. So I only have half of that circle. So I'm going to divide this by 2 and find out that that has an area of 157. All right, so that was a lot of steps, including dividing by 2 twice. I just want to explain that one more time. I divided by 2 here because that was going from the diameter to the radius. I needed that because that's what the area equation uses. It uses the radius. Then I divided by 2 here because I only have half of the circle. This equation finds the area of an entire circle. That circle has an area of 314. I only have half of a circle, so I divide it by 2 and find out that the top half of that circle has an area of 157. Now I can put these two together. Trapezoid plus the half circle on top has an area of 521 millimeters squared. All right, Miss Whitaker is making a large E to hang on her classroom door. Each piece of construction paper is about 600 square centimeters. How many pieces of construction paper will she need to make the E she designed below? All right, so we're trying to cover this with construction paper. That's 600 square centimeters. So we're trying to figure out how many it would take to cover. Actually, it doesn't even say the word cover. How much it would take to make the E that she's designing. So we're just talking about making this with a bunch of construction papers put together. It's still talking about the amount it's going to take to cover it. I'm just using that word cover. Here they use the word make. The giveaway for area is really that phrase square centimeters. That's telling us that we're talking about the area that the construction paper actually takes up. So I'm going to find the total area and then divide it by the amount that each construction paper actually takes up. So I have to figure out how to split this up. I'm going to split it here, here, and here, and treat this as 1, 2, 3, 4 separate rectangles. All right, these lines, those lines mean that those lengths are congruent. Congruent means that they're equal. So each of these is 14. That's labeled as 14. So that's also 14, that's 14, that's 14, and that's 14. So I have 4 rectangles. 1, 2, 3, 4 rectangles that I'm going to find the area of. Area of a rectangle is length times width. So length times width, 12 times 70, that's 840. Length times width, 50 times 14, that's 700. This length and this length have to be the same. That's the exact same rectangle, so I have another 700 in there. And then 25 times 14, that's 350. So I have 840, 700, 350, and another 700. We add those up, that gives us 2,590. That's the total area of that E that she's making. We're going to split that among these construction papers that each take up 600 square meters, 600 square centimeters. So we're going to divide there and find out that we would need 4.32 pieces of paper to exactly cover it. Unfortunately, we're not going to get a third of a piece of paper, so we're going to need that fifth piece of paper, so she's going to need 5 pieces of paper. All right, we're going to do a few more examples. Here, I'm seeing a rectangle and a half circle. Yes, my outlining there is terrible. I'm going to just try that again. Rectangle, half circle. Rectangle is the easier one. That is length times width. That's 12 times 30. That has an area of 360. I'm going to redraw that circle just so I can see what that 15 is talking about. 15 is going from the edge to the middle of that circle. That's the radius of the circle. Remember, area of a circle is pi r squared. That is the radius, so it's not like the last one. I don't have to divide this by 2. That's already the radius. That's the number I'm going to plug in there. Pi times radius squared. Sorry, I jumped to that. Radius squared, 15 squared, is this 225. So the full area would be 706.5. That's if I had the entire circle. I only have the bottom half of that circle, so I'm going to divide this by 2 and find out that that has an area of 353.25. The half circle plus the rectangle is a total of 713.25. All right, so you want to put fertilizer down in your backyard. Each bag of fertilizer will cover 50 square meters. Cover, square meters, we're talking about area. So later you're going to see word problems mixed together between perimeter and area. You just have to know that square meters and the word cover both mean area. How many whole bags of fertilizer will we need to buy? So we're trying to cover this, so I'm going to split it right there. I see a rectangle and another rectangle. This rectangle has a length of 20 and a width of 4. 4 times 20, that's length times width, that's 80. 60 goes all the way across. Don't use this 60 because this is not the entire way across. This part, I know it's part of that rectangle, that's 20. That means that part has to be 40. 60 takes us all the way across. 20 takes us from there to there. That means this part has to be just 40. So it's going to be 40 times 20. That is 800. Add those two together. The total area of this shape is 880. I want to figure out how many bags I'm going to need to cover that entire shape. So I'm going to divide that by 50 and find out that it would take 17.6 bags. That's not going to cover it though. I'm not going to get 17 bags because that's going to have a little bit left over. So I need 18 bags. All right, last one. We have these 3 shapes. Julie's looking to install a new pool in her backyard. She wants to build a pool that is the largest square footage, the biggest area. Which pool design should she choose? All right, so we're not going to just judge based on the picture. We're going to find the area of each of these shapes and then compare them. So pool number 1, I see a trapezoid on top. And then the exact same trapezoid on the bottom. With a rectangle cutting through the middle. So you're going to find the area of this trapezoid. I'm not going to do it again. I'm just going to multiply that times 2. And then find the area of the rectangle. Let's do the rectangle first because that's the easy one. Length times width. length times width. That's 8 times 19.4. That's 155.2. All right, then for the trapezoid, remember area of a trapezoid. Keep coming back to the formula sheet. It's 1/2 times the height times base 1 times base 2. Sorry, I said times, I meant plus. We're going to add the two bases together and then multiply it times the height and times 1/2. So 1/2, the height of the trapezoid is that 5.7. Base 1 and base 2, again, these are pretty much interchangeable. If you flipped it upside down, they would switch. But on the formula sheet, base 1 is on the top, so I'm going to keep that consistent. Say 8 is base 1, 19.4 is my base 2. So the trapezoid has an area of 78.09. That's the area of this one. It's also the area of this one. So 78.09 plus another 78.09 plus 155.2 is 311.38. All right, now I'm going to work on this rectangle and half circle. All right, the rectangle, I'm going to use length times width. It's also a square, but I don't really care. I'm always just going to use rectangle because I know it's a rectangle. 22 times 22, that's 484. And now for the half circle. 22 goes all the way across that circle. That dashed line cuts all the way across. That's called the diameter of the circle. Area of a circle does not use diameter, it uses radius. So I'm going to have to divide this by 2 and find out that the radius is 11. So we're going to plug in 11 there and find out that the area of that circle is 379.94. I don't have a full circle. I only have the left half of that circle. So we're going to have to divide this by 2 and find out that that half circle has an area of 189.97. I can put those two together and find out that the full area is 673.97. So far, that's going to be the winner. Pool 2 is significantly bigger than pool 1. Now I'm going to find the area of this one and compare it to that. So I have a parallelogram on top. This is one of the shapes that might not be immediately clear to you, just because you're not that familiar with it. You could split it up here, like that is pretty clearly drawn into a triangle. You have the exact same triangle here, and then you'd have a rectangle in the middle. I would not do that. Actually, I don't even know if you could do that, because you don't really know this length. But either way, we have a formula that describes that perfectly. That is a parallelogram. You have a base, the same base. That's how it's different from a trapezoid. This length and this length are the same, still running parallel to each other. And we have that same height that connects those two. So it's really just base times height. Area of trapezoid is base times height, or that is our height, that is our base, 18 times 12. So that is 216. Then we have a triangle on the bottom. Area of a triangle is 1/2 base times height. It really doesn't matter which one's your base and your height, because you could turn a triangle. I'm going to say that that is my base, that's my height. So 1/2 times 18 times 11, or 99. So you put those together and get 315, a little bit bigger than the first pool, but still significantly smaller than the second one. So pool 2 is the biggest pool. That's the one Julia wants to pick. All All right, again, for area, rely on these formulas, break it up into shapes that you see here, and then use those formulas.